First, thank you for the slot, because on the schedule, the two first presentations were presentations based on offensive talks, so how to break a laptop, how to do some red team operation and so on. But my current job experience, I'm working on the blue team side. So I like to track bad guys, to find them, and to investigate incidents and so on. So that's a perfect transition for the rest of the day, I think. So let's speak about full packet capture for the masses. This presentation normally runs on a 1 hour time slot, so I only have 30 minutes. So it means that I will speed up, I will skip some slides. Anyway, I will be available all day, so feel free to come to chat, to have some, to take pictures, to take some drinks. I'm open to everybody. No, it's not working. Yeah, okay. So as said, Dimitri, I'm back. Third edition for me, and I like Greece, I like the food, I like the atmosphere, I like Athens. Tomorrow I will drive to Kalamata because we have friends there. We spent a wonderful week in Greece, so I like it. Thank you for having me again at the conference. But now let's take about the issue that we have today. I'm pretty sure that everybody in your network, you have the same issue with stalking on your wire. You have plenty of computers, servers, you have maybe multiple sites, you have multiple, you are monitoring customers in your day-to-day job. So it's really important to have a good overview of what's going on all the time. So what can we do to better see the bad guys and to detect them? And I will just start from one issue. That's a perfect example. I'm a SANS Internet Storm Center handler, so it means that I'm on duty from time to time. Yeah, I don't know, who knows the Internet Storm Center? Yeah, of course, plenty of people, nice. So I write, probably every time you hear Xavier in the podcast and so on, it's me. I'm writing a lot for the IC, and this is a real case that we had to investigate a few days ago. A guy contacted us and said, okay, my WordPress website was compromised. So nothing really malicious, because it was just the WordPress was used to send spam to the visitors instead of the normal website. But the guy would like really to know, okay, my WordPress was fully patched as usual. I'm taking care of my web server, but I don't know how the attackers came in, and I would like to know why. First question, do you have logs? Yes, of course, I have logs, and the guy sent me the Apache logs, and you saw plenty of post request to xml.rpc.php, which is the classic way to exploit a WordPress instance. But by default, when you have an Apache server, when you get post HTTP request, it will be logged, but you will never see all the parameters sent to the post request by default. If you have a full packet capture, you will see everything. You will be able to track better and to see, was it a brute force attack, which was the compromised account and stuff like this. So that's the perfect example. So to track network traffic, we have two ways to do it, at layer 3 or at layer 7. Layer 3, it's quite simple. It exists for years. Basically, everybody knows NetFlows, developed by Cisco in years ago, I think more than 10 years ago. And basically on layer 3, you have a timestamp, a source IP, source port, destination IP, destination port, and that's it. So you know, and yeah, you have other fields like the total bytes, total packets, and so on. So basically you know that there were some communications between different hosts, but you don't know exactly what's in the packet. At layer 7, so the application layer, we can have all the stuff, plus all headers and the payload, so the full packet capture. Today, we have this in next generation firewalls, IDS systems, so when they detect an alert, they can start a packet capture for a few minutes, a few seconds to try to catch the bad guy. So that's the main issue. Do we have to go with layer 3 or layer 7? Because, of course, both solutions have pro and con. Based on flows, it's quite easy to set up. Main big switches, you can deploy NetFlow, you can ask them to send the data to a server. It's really optimized storage, so you can have gigabyte of flow stored, and you can have a history of years if you have enough disk space. But of course, as I said, you lack of visibility. Full packet capture, of course, you have the full view, so you can extract artifacts, you can extract all the pictures, for example, you can extract binaries, you can extract usernames and so on. You can replay, you have tools to just replay the TCP packets with full packet capture and really see on your screen what happened. And of course, if you are doing forensics, you have nice evidences. But it costs you a lot in terms of disk storage, of course, because all the traffic is stored on your disk. Privacy, because you have in the payloads always interesting stuff, logins, passwords, stuff like this. Performances, and you need more sensors because you need to deploy sensors, so application which will listen at critical points on your network to collect the traffic. Regarding the privacy, so this is not a brand new talk. I presented the talk for the first time in January. Everybody was preparing GDPR. I presume that everybody in this room is aware about GDPR, but it was not in place. Today it is. Full packet capture means that you get plenty of data on your disk. So it's your responsibility to take care of GDPR. It's not mine, you just be warned. Okay, next step. Full packet capture, basically, you don't need a lot of tools, you don't need a lot of software to do it. Just the basic TCP dump command present in every modern Linux distribution can do this. This is a quite complex command, but if you execute this on your server, you will get full packet capture. What does it mean? You will just listen to an interface, you will sniff a packet length of 0, it means that you will get the full packet length all the time. And the most interesting parameters are -C, -G, and -W, which will in fact create some files, some PCAP files, based on the timestamp in a specific directory with a rotation. Refer to the man page to see what it means, but we will create specific files every hour. We will keep 24 hours, so 2 days of history, and if the file is more than 500 megabytes, we will switch it. And of course, we drop some interesting portion. If you execute this on your server, you will get 2 days of full packet capture. Basically, if you operate a small web server, you run a VPS today to deploy your WordPress, your Drupal, your CMS, you can run this and you will get 2 days of full packet capture. But the issue is, today, most people work in this kind of cloud. You have virtualized systems, local servers, but you have VPS, you have cloud solution, maybe you exchange data with partners, you have co-location servers and so on. So it's a mess, it's quite difficult to run these commands on every system. And then when you need to investigate an incident, you have to jump on all the servers to collect, to correlate the data. It's impossible to do. So the solution is to centralize everything in one place to optimize the retention. But we have some requirements, so that it was my requirements, but basically it's the same for most of you. Must be free, because I don't have a lot of money like everybody, so if I can use free software. By the way, I remove free by open, because a free software is never really free. You can use it for free, but it has always a cost to deploy, to maintain it, and so on. It must be easy to deploy on different OSs, because we have different flavors of Linux. You can have MacBooks, Windows system, whatever, so it must be compatible with many operating systems. And it must be deployed on systems which are not directly connected on the same location, like on the LAN. If all the systems are on the LAN, it's quite easy to centralize something, but if you have systems split across multiple locations, it may become an issue very quickly. So the first tool that I'm using to do this is Moloch. Who is aware of Moloch? 1, 2, yeah, not a lot of people. Moloch is a very nice tool. So I will not do it, that's just a description of Moloch, but in my opinion, that's the best full packet capture tool, because in one web interface, you can search for packets. It's like a Google for packets. In fact, you can apply filters. It's a mix of Google and TCP dump in a web interface, But you can also extract files, you can extract flows, you can extract pictures, you can reconstruct all the flows, and it's very powerful and, most important, scalable. What are the different components of Moloch? You have the first one is a capturer, which is really the tool which will sniff the packets. It can sniff online or offline. For example, often I'm using Moloch to do investigations. If a customer sends you a PCAP file, you can just offline inject it in Moloch and you can review it and make your investigations. It uses, of course, a huge database based on Elasticsearch, and it has a viewer, which is really the web GUI. And this is a nice screenshot of Moloch. So it's like a mix of Splunk, TCP dump. You have the history, you can see from where your packets are coming because it is doing geolocalization automatically based on the IP addresses. And you have all the flows with source destination, number of packets, and if you click and expand the flow, if there are some pictures, there are some interesting DNS requests, so everything related to layer 7, you will be able to process them. So the solution basically will be based on Moloch. The next tool, I'm a very big fan of Docker. Docker, basically, I used it because you can run it on also any operating system, so it's quite easy. The support is not so bad. I had some nightmare stories with Docker because from time to time it crashed and you have to restart everything, but usually you can run it, it's quite stable. Second warning about Docker. Misconception, a lot of people think that Docker is virtualization. It's not the same. From a security point of view, Docker is a mess. So it does not mean that if you run an application in a Docker container, it will be fully segmented and it won't be able to access the host operating system and so on. So I'm using Docker only as a way to quickly deploy, which is the goal, the primary goal of Docker. Basically, Docker is a tool for developers. It's not a tool for security analysts, security people. The goal of Docker is really to, for example, run multiple versions of the same tool in development systems just to test, to debug and so on. It's not a security tool. So later I will show you the configuration is made in a way that it's not very secure, but I have to do it. So when you have an ID, say, okay, I will do full packet capture. I need I have an ID, but I need some tool. The first thing that you do usually is you Google for it, because probably somewhere in the world another guy had the same issue and already write something. So that's what I did. And I don't remember the year, but a few years ago, a guy, Mauricio Espinosa Gomez, wrote a GIAC gold paper about this. So it's exactly what I'm looking for, a full packet capture, centralized system with multiple sensors. Perfect, so I read the paper, I checked, okay, may I reuse it? And the first approach of the guy is, what's very nice, it's fully automated using Puppet, another tool well known by developers, sysadmins and so on. But for me, the biggest issue was the multiple nodes in Moloch. Because the guy deployed a Moloch on every sensor, and Moloch was, because Moloch can also be used in distributed way, but you had multiple instances of Moloch, and Moloch is quite resource extensive. So for me, it was not the biggest, the most, it was not really interesting, and also Elasticsearch must be reachable from sensors. Probably you know that putting Elasticsearch online or facing the internet is a very bad idea. So it means that to deploy this solution, you need to run it on top of a VPN, MPLS cloud, stuff like this. So it was quite annoying for me. So I decided, okay, my approach, and the goal is to deploy Docker containers as a sensor with very limited set of tools, and to just send the PCAP files to a central Moloch at regular intervals. Quite easy. So the infrastructure is very simple. You have the red cloud, can be the internet, can be MPLS, can be whatever you want. It can be trusted or not, as you want. You deploy multiple sensors, they send to Moloch, and Moloch to Elasticsearch. So I have a single instance of those tools, And my sensor is really, really small. The goal was to have a very small footprint, so to not interact with other applications running on different hosts. And the analyst, so the handler, that's me, I'm just connecting to my Moloch using a remote access and so on, and I'm able to work. Moloch. So there are some good containers, because if you run containers to deploy the sensors, you can also run containers to deploy Moloch. But again, you are searching for an existing one and you find it nice, but you can improve it. So what I did is to add some persistence, because of course if I need to restart my container, I need to get my PCAP back. And also an automatic indexing of all the PCAPs, no live mode. This is the command to run the Moloch capture, so in the Docker, blah, 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 I refer to documentation. I'm speeding up, sorry, because I don't have a lot of time. This is the configuration from the Docker compose to start the Moloch server. Slides will be online, so you will be able to write it, and everything is available on GitHub. Then you start your Moloch server just by compose up, and you can access it on port 8005, which is the default one. The sensor, in fact, has two components: TCP dump and send the files using SCP. So to deploy a sensor is quite easy, because everything is in GitHub. So you go to your host, you do a git clone, cd sensor, you build the Docker, you configure it, because of course you need to specify a minimum configuration, like which kind of interface you would like to sniff, capture size, or how many files you would like to get. This one is quite interesting to remove non-interesting traffic, of course. The sensor name, the target. So it means, in fact, that's the Moloch. So you see the PCAP file will be sent to this server. You can, of course, provide some arguments. For example, I'm running on a high port, not on the default 22. And, oh, that's bad, but I will not check the SSH keys all the time. And when you boot the sensor for the first time, you get, of course, it generates a SSH key, and the only manual action to do today is just this SSH key. You have to copy it and install it on the Moloch server to automate the configuration and the reception of the PCAP files. Big warning, so I said that the Docker is not a security tool. To let Docker access the physical interface to be able to sniff packets, you need to specify .NET equals host. So it means that you break all the segmentation between Docker and the host, and the container will have access to the host. So big warning about this, but I don't, if somebody has an ID, but I don't found an alternative today. Some tips. So use BPF filters to reduce the noise. If you know that you are using RDP, SSH to maintain your network, and it's a trusted protocol, skip it, so you will not increase the size of the PCAPs. And a very interesting feature, you can also don't save BPF for some ports, but you can also save for specific connection like SSL to HTTPS. By default, today, plenty of websites are running over HTTPS. So you will collect gigabytes of HTTPS traffic, but if you don't have the key, you will not be able to decrypt it. So using this specific command, port 2210, it means that you will only log the 10 first packet of the flow. So you will log the flow, you will have a full packet capture, but only for the 10 first packets, which is nice, and you will not flood your disk with unreadable data. I found this one, it's a bug in Moloch, in fact. In TCP dump, you can run, you can sniff on a specific interface, -i, th0, th1, whatever you want. But you can, if you don't specify an interface, it will run by default on any interfaces. But the PCAP file will be different. If you run, which one is it? Yeah, if you do any, you have a Linux cooked TCP PCAP file. If you specify an interface, you will have an Ethernet capture blah blah file. The format is not the same, and Moloch will not be able to handle this one. So, my solution, no footprint on the sensor because it's a Docker, so you just drop the Docker and you don't have any component remaining on the stem. You don't have remaining libraries, binaries, stuff like this. If it runs on Docker, you can run it on any system. I'm using SSH to transfer the PCAP files. It's quite easy to tune because using environment variables, you can specify the interface, the size of your PCAPs, and so on. The big issue, you don't have real-time processing. So it means that on my infrastructure, I'm pushing the PCAP files every 30 minutes, I think. So it means that if I need to investigate something, I need to wait 30 minutes to get the last packets. It's not real-time, but for me, it's completely acceptable. Small risk of broken throws, and also all the packets in Moloch as Moloch will index local files, all the packets will be tagged as coming from the same node. So we will not be able to search for packets coming from server 1, server 2. You need to search on the IP address of the node. If you want to test everything is online, I think I should upgrade some files soon because there are some optimization that I have in my mind. I still need to find time to implement them, but it's live. And it's my last slide. Thank you very much. Any questions?